Now we will start talking about energy changes in chemical reactions. In any chemical reaction, as we have changes in the chemicals, also we have changes in the energy of the reaction. Changes in the energies of the reaction shows as the temperature or the heat of the reaction that is changes, also the temperature. We will have rise in temperature or decrease in the temperature of the reaction. That's why we have two types of chemical reactions according to the change of energy. The first type is the exothermic reaction. Exothermic reactions are the reactions that give out energy. So the temperature in these reactions rises up. So if we have any reaction that the temperature rises up, so this is an exothermic reaction, so the energy is given out. The equation is written this way. Reactants gives products and energy. So reactants, then products plus energy. The energy level diagram is drawn this way. The reactants, energy is given out to give out products. Okay, now I have to mention that the energy in the reactants should equal the energy in both the products and the energy that is given out as temperature rises. Okay, so that's why here the reactants, they have more energy than the products, because the sum of the energy of the products and the energy that is released out of the reaction should be the same as the energy in the reactants. That's why reactants, they have more energy than the products. We have some examples on these reactions, the exothermic reactions. The neutralizations, any neutralization reaction of acids and bases. The combustion reactions of fuels. Any fuel, when we burn it, it will give out energy, so it will be an exothermic reaction. And respiration reactions that take place in our body cells. The second type of reactions is the endothermic reaction. The endothermic reactions are the opposite. They take in energy. So the temperature in these reactions will decrease. When we write the equation for these reactions, we have to write reactants plus energy and then the products. And that's why the energy of the reactants is less than the energy of the products. That's why we draw the energy diagram or energy level diagram this way. Reactants given energy, so energy is taken in, and then we have the products. That's why products, they have more energy than the reactants. Some examples on these reactions: decomposition reaction. Any decomposition reaction, it will be endothermic reaction. Reactions that take place in cooking, when we cook, these reactions are endothermic reactions. And photosynthesis also is an endothermic reaction. Okay, how does the energy change in when any reaction takes place? We have something called bond energies. Bond energies or bond energy is the energy needed to break bonds or release when these bonds form. So we have bond breaking and bond formation. Bond breaking and bond formation, they both take place when any chemical reaction occurs. In any chemical reaction, we have two things: bond breaking and bond formation. The bond breaking is always an endothermic reaction because we need energy to break up the bond between any two atoms. But the bond formation is an exothermic reaction, so when any atoms, two atoms, react with each other, they will give out energy in order to thus to take place, to the reaction to take place. So it's an exothermic reaction. And this is why any chemical reaction could be exothermic or an endothermic. It depends on which one is more. The energy that is needed to break up the bonds, or the energy that is released when any bond is formed. If the energy that is needed to break up the bonds is more than the energy released, so this reaction should be endothermic. When the energy that is released when the bonds are formed, then this reaction will be an exothermic reaction. And going from here, we have to calculate something called heat of reaction, delta H. Delta H, or heat of reaction, is the energy change in any chemical reaction. Delta H could be negative or positive. If delta H is negative, then this is an exothermic reaction. If delta H is positive, then this is an endothermic reaction. Now, we will solve an example to calculate delta H from bond energies. This is the example. We have these two reactants, and these two products are given out. The question is, use the following bond energies to determine whether this reaction is exothermic or endothermic. These are the bond energies that we will use in order to solve this equation, or this example. These are the types of bonds, and these are the bond energies in kilojoules per mole. First of all, we have to know the types of bonds in each reactant and in each product. Starting with this reactant, we have the bond between carbon and carbon, one bond, and the bond between carbon and carbon, two bonds. So we have two bonds of the type carbon and carbon single bond. So when we start solving, we will write reactants. So delta H in the reactants, in the bonds breaking in the reactants. First of all, we have two bonds, carbon and carbon. Second, we have carbon and hydrogen. Carbon and hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 CH bonds. Also, we have chlorine and chlorine. There is one bond between chlorine and chlorine. So 1 Cl, Cl. We will take the values from here. This is the ClCl, 242 kilojoules per mole. So 1 multiplied by 242. Okay, carbon and carbon, 348. 2 multiplied by 348. And carbon and hydrogen, 412. So 8 by 412. This, when you calculate it, it will be equal to 3,296. This one, 696. And this one, 242. 42. Now we have to sum all of these. The summation will be 4,234 kilojoule per mole. This is the energy needed to break up the bonds in the reactants. 4,234. Now let's go to the products. Now the products. Okay. Also we have carbon and carbon. 1, 2. So 2 bonds. Carbon, carbon. Carbon, carbon, 348. And this will equal to 696. And we have carbon and hydrogen. 1, 2, 3, 4, 5, 6, 7. So 7 carbon, hydrogen. 7 multiplied by carbon, hydrogen, 412. And this is equal to 2,884. Also we have carbon chlorine, 1 bond. Carbon chlorine, 338. And the last one, we have hydrogen carbon bond. So 1 bond, HCl, HCl, 431. If you sum up these, the answer will be 4,349 kilojoule per mole. This is the energy released from bond formation in the products. Now delta H is always equal to energy needed to break bonds in the reactants minus energy released when bonds are formed in the products. So in this example, in the reactants, the energy equals 4,234 minus, in the products, 4,349. Delta H equals to minus 115. And since it is negative, we will go back to this. Negative delta H means exothermic reaction.